In the figure below, the long straight wire carries a current of 6.9 amperes. Find the magnitude of the net force on the rigid square loop of the wire of the side L equals to 5.68 centimeter. The center of the loop is 10.7 centimeter from the wire, and the loop carries a current of 10 amperes. Okay. Now, first of all, let's try to understand the directional magnetic field that was created by the current 1. Now, using the right hand rule, we can see that the upper side of the current 1 is out of the page, okay, and the bottom side of the long wire, so this is a B1, bottom side of the long wire will be into the page, okay, so into the page. And as you can see that as the radius gets the longer and longer, the magnetic field becomes a weaker and weaker. Why is that? Is because the B1 is equal mu naught current 1 divided by 2 pi r. Okay, as you can see, B1 is inverse proportional to the 1 over r. Okay, now the second thing is that we have to know is the direction of the magnetic force that was acting on the wire 2. Okay, so magnetic field is created by the current 1 is into the page, and then direction of the current is like this one, right? So the force, so magnetic force will be on the, so let's say that if you take the wire, so into the page, the current going up, the force will be basically like this one, okay, and as it gets further, the force will start decreasing. Why is that? Is because the magnetic field strength gets less and less. So this one I call it the F1. Okay, then what about this side? So this side will be the same. Gets less and less. So this side I call it F2. Okay, so as you can see here, the magnitude of F1 and F2 are the same, but direction is opposite. So therefore, we can say that F2 plus F1 is equal to 0. Okay. Now the next thing that we have to find is a directional magnetic field on the top wire and the bottom wire of the square loop. Okay. The bottom one will be basically will be a bigger, so I would call it like this one. Okay, so I call this one as a F3, and that side will be the magnetic field, it gets less. So in that side should be like this one. This one I call it F4. Okay, so that means we can say that F net is equal, now whatever is pointing downwards I call it negative, whatever is pointing up I call it positive. Okay, so that means negative F3 positive F4. Okay, now the F3, the magnitude of F3 will be equal to the so before finding it I have to show what is the distance of this one. What is this distance? So that one I call it S, and then that distance I will call it as x, okay, x. So the s distance, first of all, s distance is equal to the d minus, so this is the half of it, right? This is a half of it, so L over 2. That means s distance is equal to the d minus L over 2. Okay, now what about x distance? The x distance is basically d plus L over 2. Okay, that's it, I think. So now let's find the F3 magnitude. F3. The F3 will be equal to the mu naught current 1, current 2, the L, because L is a square, so everywhere is L. This is also L. L divided by the 2 pi S. Okay, or you can say is mu 0 current 1 current 2 L divided by 2 pi d minus L over 2. Okay, then what about F3 and then F4? The F4 will be mu 0 current 1 current 2 L divided by 2 pi x, or you can say mu 0 current 1 current 2 L divided by 2 pi, our x is equal d plus L over 2. Okay, so that's it. Finally what you have to do is that you have to find F net. F net is equal minus F3 plus F4, which is equal to the negative mu 0 current 1 current 2 L divided by 2 pi d minus L over 2 plus F4 is equal to the mu naught current 1 current 2 L divided by 2 pi d plus L over 2. So that's it. If you plug numbers, you should get the right answer.